Okay, let's unpack this. If you are building anything modern, especially, using frameworks like Next.js and deploying on platforms like Vercel, you have lived this nightmare.
Oh, absolutely.
You're developing the features, everything is compiling perfectly, you run npm run dev, and the site is beautiful.
It's working.
It's loading data, hitting your endpoints, looking crisp. You feel invincible. You commit your changes, push to GitHub, and instantly the deployment just explodes.
It does. You get that sinking pit of your stomach email,
Ugh.
build failed.
Ugh, the worst.
It truly is the ultimate developer betrayal. What works flawlessly, locally, suddenly seems to offend the production environment.
Yeah.
Today, we are undertaking a very focused deep dive into this specific and intensely frustrating scenario.
Right.
We're identifying the two core villains responsible for this failure: the forgotten, conflicting pieces of code we are calling zombie files, and then the surprisingly stubborn cloud platform cache that aggressively clings to those errors even after you've fixed the code.
So our mission today is really to give you the definitive roadmap for diagnosing this specific Vercel build failure, hunting down those digital zombies that are breaking your deployment logic, and most importantly, giving you the guaranteed, albeit drastic measure you need to clear that platform cache.
And finally get that beautiful, solid, green, ready state.
Exactly.
We're ready to dive into the conflict, the diagnosis, and what we're calling the nuclear option. Let's get started.
So let's start with that local illusion. Why does the project run perfectly on localhost when we use npm run dev, yet Vercel just throws a fit? What's the fundamental difference there?
That's the critical distinction. When you run npm run dev, you're basically running a server in development mode. And this mode it's extremely forgiving.
Okay.
It prioritizes fast, hot reloading and interpretation of your code. It often resolves paths dynamically and just lets ambiguity slide, especially if a file isn't explicitly being called on that specific render cycle.
So if I have two files fighting over the same path, but I'm only looking at the homepage in my browser, the dev server just, ignores the fight?
It ignores the fight until someone actually tries to load that conflicted page.
Okay.
Precisely. Now, when Vercel attempts to deploy, it doesn't use the dev server. It runs the full production build process, usually initiated by running npm run build. And that build process is rigorous. It optimizes, compiles, and statically analyzes every single file to determine the final routing table for the serverless functions and pages. It's during this critical compilation stage that all those ambiguities are flagged as catastrophic errors.
So running npm run build locally is the cheap and essential way to replicate Vercel's pain.
It is.
When the developer and our sources ran this command, what was the smoking gun?
The error message was crystal clear, and it immediately bypassed any complicated logic concerns about databases or, authentication. The system reported, you cannot have two parallel pages resolving the same path.
Okay, that's direct.
It immediately told the developer, the problem is structural. You have multiple files claiming the exact same URL endpoint.
All right, that brings us to the hunt. We need to define these zombie files because they are the root cause of this whole structural breakdown.
A zombie file is essentially technical debt left behind. It's an older file, maybe from an architectural shift, that wasn't properly deleted or renamed when a new correct file structure was introduced.
So it's just lying there.
It's just sitting there, inert in development, but it wakes up during the strict production build process, demanding resolution for a path that has already been claimed by a newer file.
Okay, let's analyze the first major conflict they found, case study 1, the login conflict. What specific structural mistake was causing that clash?
This is a textbook example of path duplication. The developers had successfully implemented a new, correct API route for authentication, let's say something like a papioth-login.js. This file was the intended endpoint handler.
Right, the correct one.
However, back in an earlier iteration, they had a forgotten, loose login file sitting higher up in the general page structure, maybe something like a plugindex.js or even a similarly named file in a root folder that was meant for an older flow.
So the moment the build process saw both files, the new API file and the old page file, it tried to map both of them to login.
Exactly. The compiler throws its hands up because it cannot map two separate entry points to the same route. In this specific case, the old login file was the zombie. It wasn't being used, but its mere existence in the file tree created the fatal path collision.
And the fix.
The fix was straightforward but crucial. Systematically locating that forgotten login file and either deleting it entirely or renaming it safely. maybe by prefixing it with an underscore, like old login.js, which prevents the compiler from seeing it as a route.
That seems like a clean kill. But as often happens in complex projects, fixing one bug it reveals the next one.
It always does.
After eliminating the login zombie and running the local build again, the login error vanished, only to be immediately replaced by a new failure related to products,
Which confirmed they were dealing with a multi-file infection. The products conflict, case study 2, was structurally different, but resulted in the same 2 parallel pages error. Here, the mistake was an inversion of the intended architecture.
An inversion? Tell me about that.
So the project had a functional API structure for handling product data updates using the designated API paths. The correct handler might have been a file called handler.js or something similar inside the products folder. However, the developers had mistakenly placed a page.js file intended strictly for front-end rendering inside that API-related folder path, something like a products page.js.
Wait, so a file designed to tell the framework how to render a UI was sitting in a folder that should be dedicated purely to serverless function endpoints.
That's the inversion. It's a complete conflict of intent. The router is looking at the products path. It sees the API handlers, and then suddenly it sees a page.js attempting to claim that same route path for front-end rendering.
Wow.
This creates a severe structural conflict because the framework cannot reconcile a serverless endpoint with a client-side page component at the identical file system location.
I can see how a tired developer could make that mistake. Moving files around and just forgetting the specific meaning of page.js versus an API route handler when you're nested that deep.
It happens.
So the resolution was the same. Hunt, locate the misplaced page.js inside the product API path, and delete it.
Exactly. So after eliminating the login zombie and the product zombie, the developer ran npm run build one last crucial time. The local build succeeded. It showed a message confirming successful compilation. The code was clean. The fix removing those 2 file conflicts was committed to GitHub under a clear message. Fix remove zombie. On the code side, the war was won.
But now we move into the domain of, platform politics. The code is fixed, the build passes locally, the developer pushes the clean code, triggers a redeploy on Vercel, and somehow Vercel fails with the exact same original path conflict error.
It is absolute madness.
You see the code fix in GitHub, but Vercel is still deploying the ghost of the broken code. This is the infuriating moment.
It is. You look at the commit history, you know the files are gone, but the Vercel logs are still referencing the deleted zombie files. This is the aggressive cloud cache at its worst. And our sources confirm this stubborn error persistence is highly prevalent on Vercel's free and hobby tiers.
Okay. Why is the cache so aggressive on these tiers? If I commit new code, shouldn't the platform be smart enough to know that the build dependencies have changed?
You'd think so. But it comes down to speed and cost optimization. Vercel, like many automated platforms, uses layers of caching to speed up build times. If you've done multiple sequential deploys, especially failed ones, the platform can aggressively cache the previous state of the entire repository or the precompiled assets. The goal is rapid deployment. But when you have a deep-seated structural error involving file paths, the cached metadata about those files often takes precedence over the fresh Git pull, especially if the internal cache key isn't properly invalidated by the simple Git commit.
So solution A, the standard redeploy with cleared cache option that Vercel provides, is often not enough in these deep conflict cases. It just sort of scratches the surface.
That is correct. Standard cache clearing attempts often fail because the deep structural knowledge, the metadata about which files claim which paths, is still stubbornly held by the Vercel system. The error persists.
This brings us to solution B, the nuclear option. This is what the source material refers to as the only guaranteed method to truly force a zero-state deployment. I have to ask you before we detail the steps, is there really no lower-level CLI command Vercel could offer that bypasses this without requiring us to delete the whole project? That seems excessively violent for a caching issue.
That is the frustration. If you're on an enterprise tier, you often have more granular control. But on the hobby tiers, Vercel deliberately simplifies the interface. The lack of a transparent, low-level cache-flushing utility means that developers are forced into this extreme measure.
Oh.
For the listener needing a guaranteed fix today, deletion and recreation is the safest route to cache purgatory.
Okay, let's detail the steps for the listener who finds themselves in this painful loop. How do you execute the nuclear option safely?
Safety is paramount. But remember, your clean code is secure on GitHub. First, you must go into your Vercel project settings and delete the entire project.
The whole thing.
The entire thing. This immediately wipes all Vercel side metadata, all accumulated cache layers, and all deployment history related to that specific Vercel project ID. You are sending a signal. I am starting fresh.
Okay.
Precisely. Step 2. Return to your Vercel dashboard, select Add New Project, and re-import the exact same repository from GitHub. Vercel now sees this as a brand new project with no prior history or cache dependencies.
And what's the crucial piece of information the developer must secure before deleting the old project?
Environment variables. That's step 3. You must remember to secure and re-import all necessary environment variables, API keys, database connections, all of it, that were tied to the previous project instance.
Right, don't forget those.
Once those are re-imported, you run the deploy from this new, clean project shell.
And because Vercel is forced to perform a true zero-state build, downloading the clean code fresh from GitHub and analyzing the repository without any poison cache, the build finally succeeds.
And you get the green functional site.
That's an unbelievable workaround. The kind of frustrating tribal knowledge we're forced to accumulate to use these automated systems efficiently.
It is the guaranteed fix when the platform is just being obstinate.
This entire ordeal, while painful, provides some tremendous insight into modern deployment pitfalls. Let's synthesize this into the 5 golden rules of deployment for 2025.
Yes.
These are the preventative measures every developer using Vercel or similar platforms needs to commit to memory.
Absolutely. We need to internalize the lessons learned from the zombie files to prevent these structural conflicts from even happening in the first place.
Okay, so rule number 1 addresses the most basic path conflict. Mind your pages and your JS files.
Yes. Never create a standard, unnamespace JavaScript file in the same folder that already contains a page.js file. The page.js is the designated authority for that route's front-end render. If you drop a loose JS file next to it, the compiler sees 2 pages fighting for the same URL, and that triggers the first type of zombie failure we saw.
Right. Rules 2 and 3 focus on maintaining the purity of your API structure, preventing that whole case study 2 problem.
Rule 2. API endpoints must always be placed strictly and only inside the designated API folder structure. This compartmentalization is just non-negotiable for modern routing. And Rule 3 is the corollary. Never create a page.js file inside any folder that is part of an API path.
Simple as that. If the folder is for server requests, no client-side rendering files. These 3 rules, separation of concerns, path clarity, and API purity, they seem like they'd eliminate 90% of these zombie file errors. So Rule 4 is the local test that saves you hours of remote deployment time.
This is gospel. Always, without exception, run npm run build locally before making any commit or push. That local build test is your litmus paper. If it passes successfully on your machine, you have extremely high confidence it will pass on Vercel.
And if it fails locally,
do not waste your time pushing. It will fail remotely 100% of the time.
And finally, Rule 5, the cache contingency, for when Vercel is simply refusing to move on.
If you have followed Rule 4 and the local build passes, but Vercel still throws an error referencing a file you know you deleted, first, attempt a standard redeploy. But if that fails, secure your environment variables immediately. The only guaranteed fix is to delete and recreate the entire project.
It's harsh.
It's harsh, but it's the necessary path to a clean slate.
This has been a deeply practical deep dive. We've identified that the nightmare of Vercel build failures often boils down to structural path conflicts caused by these forgotten zombie files, like that conflating login route and the misplaced products page sitting inside the API folder. And crucially, we learned the extreme but essential solution for persistent cache issues on automated platforms: total project deletion and re-import to force a true zero-state build.
The essential knowledge gain here is understanding that tension between platform convenience and developer control. We are relying so heavily on systems like Vercel to handle our infrastructure seamlessly. But the fact that developers on the hobby tiers must resort to deleting an entire project instance, a procedure that feels fundamentally wrong and risky.
It does.
Just declare an aggressive cache raises an important question. What hidden infrastructure limitations or design choices force this extreme dependency on project recreation? And how much control over the deployment process are we truly sacrificing for the convenience of one-click hosting?
Something to mull over the next time your local host tells you everything is fine, but the cloud says otherwise.
All right, everyone, that wraps up today's episode. If you want to dive deeper and watch the full video, hit the link in the pinned comment. Just a heads up, the original recording is in Portuguese, so make sure to turn on the English auto translation. It only takes a second, and it makes everything super easy to follow. If this episode brought you any value, do me a favor. Like the show, share it with someone who might enjoy it, and drop a comment telling me what you want to hear in the next episodes. See you next time. Next.